And you say, well, okay, what about the spring? How does that work? You call that gas kind of a spring. Well, this is called blanket gas. All right. And that is what resides above the surface of this heat medium. Blanket gas is never air. And the reason it's not air is because this is a heating oil, which is combustible, and you're gonna heat it to, worst case scenario, you're gonna heat it to 400 degrees. So you really don't wanna have air in here and have a little bit of vaporization take place. Now suddenly I've got a combustible mixture above this and it's not safe. So for blanket gas, the gas of choice is methane. That's what's usually available and it's cheap, and so you use methane. And you say, well, gosh, that's combustible. Why would I put a combustible gas over what I think could be combustible here? It's only combustible if there's oxygen. So you're gonna use methane in the absence of air, and so now I don't have anything combustible. And you obviously, when you're using that, you've got to go through a process of pushing all the air out and making sure that you fill this with 100% methane. So you want to take that time to purge out this air, push it out, and make sure that you end up with 100% methane as your blanket gas, okay? So how do you get it in there? How do you keep it so it's regulated? Normally what we do is this is a pressure supply. Let's say you've got 100 pounds here coming in. This would be regulating it down to, let's say, 15. So I'm gonna have 15 on this side of the regulator. And so I start off with, hey, I've got 15 pounds above this liquid. Now I start heating the liquid. Well, when I start heating it, the liquid level goes up and I start compressing this gas. And when I compress it, what do you think happens? Well, this 15 pounds suddenly goes higher in pressure. Well, I've got a relief regulator on this side that's set at, let's say, 30 PSI. That means that as I begin compressing it, it begins to move up. I get to about 30, and this expansion drum starts burping a little bit, and it stays at 30 PSIG pressure. If it goes back down, the pressure drops. As it cools, I might have a little more gas pushed in here. If there's a really big time upset condition, you also have a PSV on here. And I'm not going to draw that symbol right, but I think it looks something like that. Kinda. That looks terrible. I know that's not right. But it's a PSV, and you would set that, let's say, at 150 PSIG. Why would you set that at 150 PSIG? Well, the design for this is a pressure vessel. The design for this is going to be the same pressure design that you have for the coil on the heater. So if you design the coil to take 150 pounds, you want to design the expansion drum to take 150 pounds. And so that's your design, and that's what your PSV could be set at. Now, a lot of times people will say, well, I'm going to set this PSV at like 70 pounds, just to be safe and make sure I don't ever go over the design of the vessel. And that's okay too, because remember, this vent's set at 30, so you should never get to 70 PSIG unless something failed with this back pressure regulator. One other thing about expansion drums is what elevation do you put them at? The absolute foolproof method is to put them the highest in the system. You can do that. It could be fairly high, it could be 30 feet in the air, so there's a lot of structure to do that. Most of the time, they're not that high. Most of the time they have some elevation, maybe 15 feet, because you want to put some good NPSH on this pump inlet, but normally they're not the highest in the system. Sometimes they are. Some customers want that just as a foolproof way of doing it, but you don't have to. Okay, so the takeaway is, one, make sure it's big enough. Make sure you do all your math, you calculate all the volume of pipe and coil in this system, and you do the math of what the density is at 40 versus the density at 400, and make sure that you don't undersize that. And then secondly, make sure that you design it for 150 psi-G, and obviously you want to make sure that it's designed for something north of your absolute highest temperature in your heat medium, and you'll be good.